And now we're going to be talking about the most relevant industries for chemical engineers. Hey, what is up guys? Welcome once again to the channel. It's always great to have you back, and if you're new, don't forget to subscribe. In this channel we talk about chemical and process engineering for both students and professionals, so don't forget to subscribe and ensure to click on the notification bell. Either way, subscriber or not, it's great to have you here. So what I want to do in this video is to talk about all the relevant industries that chemical engineers have been taking historically, that maybe, I don't know, maybe traditionally, but of course what are the newest trends or newest industries that have been relevant for chemical engineers nowadays. I'll be presenting the industry, talk a little bit on what are they doing right now, what is the main focus on the industry, if the industry is growing or maybe it's stagnated already, and of course other comments that may be relevant for you guys. One of the most important things to consider, guys, is that there is no same job position, no same company, no same industry. So it will be very hard to compare a process engineer working for the cement industry versus a process engineer working in a refinery, or maybe a project engineer working for the automobile industry versus a technical sales engineer working for the pharmaceutical industry. So don't be harsh on you guys and don't force a single industry on you. If you like maybe pharmaceuticals, be open for other type of industries. There's a lot of industries in which chemical engineers can work on. But anyways guys, let's continue to the industries. The very first industry I selected is of course one of the largest ones and also one of the biggest employers of chemical engineers, but also very important for the economy of the whole world. And no guys, I know that you are probably thinking on oil and gas, which of course I consider, but the best industry for chemical engineers is of course the, drum roll, yes, chemical industry. And I know guys that maybe you're wondering, wait, what? Chemical industry? Isn't chemical industry composed of other several industries? And yes, but what I mean mostly is for bulk chemicals that are made in huge amounts. Technically speaking, they are commodities. For instance, sulfuric acids or bases such as ammonia, maybe hydrochloric acids, gases such as argon, nitrogen, oxygen, chemicals used for solvents, maybe glues, maybe construction materials, coatings, paintings, pigments, detergents and soaps, textiles, and much more. You will need always chemicals for further production of other chemicals. So you always need the typical feedstock or raw materials or commodities that are out there. So why do you need acids? Typically because you need solvents or acidic media to produce other type of materials. So why do you need gases? Typically because you need either a inert gas such as nitrogen, or maybe you want to burn fuels in a very high efficiency, hence oxygen. As you can imagine, there are a lot of chemicals that require previous chemicals. Hence the name bulk chemicals or basic chemicals or so on. They are so basic, they are feedstock, they are raw materials, and they are required in very large amounts. So just for the sake of curiosity guys, go out and Google and check out for the nearest chemical company. It can be producing chloralkali industry, which is very common. It can be something creating building materials such as cement. It can be also maybe paintings, coatings, pigments. It can be also textile material. There are many chemical industries and I'm pretty sure you can find one near you. So let's talk about more on this industry. It is growing steadily, it's not stagnant. We are growing in population, therefore we are growing in demand of chemicals, meaning that this industry is steadily growing. It might not be the most explosive industry, but it's also not a stagnated industry. And actually, many of the processes you will encounter there are very chemical engineering, meaning that it's not mostly mechanical engineers working there, but they require chemical engineers that know about processes, how to treat substances, and so on. And therefore, this is why I consider the chemical industry one of the best industries for chemical engineers. The second industry I have for you guys, it's pretty similar to the first one, and maybe you can make a case or argue that this is technically speaking also a chemical industry. And I'm talking about agrochemicals. As the name implies, these are chemicals that are focused towards the agriculture. As you can imagine, we require a huge amount of food and beverages, which typically come from agriculture. You require huge amounts of crops or feedstock for animals as well. And you require a lot of things in order to have healthy crops. For instance, you require very nutritious land, meaning that you will most likely be adding fertilizers. Also, you need them to be away from plagues, so you will need pesticides. And also other little things such as herbicides or other materials that enhance the crop production. Talking about the industry, it's a very promising one, since the challenge of growing even more crops, healthier crops, and cheaper crops are always there. So improving fertilizers, pesticides, herbicides, and a lot of agrochemicals in order to favor the growth of these crops is always an important issue. Not only that, as we are growing in population, we are requiring each day much more crops. With respect to the actual industry, I will say it's a growing field. It's not so stagnated like average chemical industry, so that's why they're separated. It could be said that it's actually a growing industrial field. Let's go to the other side of the coin, which is petrochemicals, or overall I would say oil and gas industry. Even though I will say that mostly petrochemicals is what a chemical engineer will be doing, but don't take my word for granted. I know that there's a lot of chemical engineers going directly to the upstream production. And for you guys that may not be that familiar with the oil and gas industry, upstream is essentially when you get into the production sites. So you're drilling and you're production and you are producing or extracting the crude oil, maybe very basic treatments, removing gases, separating liquid gas, maybe even sweetening or so. And then you take those two products, so the gas goes to natural gas and the crude oil will go to the refinery. Once in the refinery, we're talking about downstream, which is the treatment of crude oil and converting crude oils mostly into fuels. And a very small part, maybe between 5 to 7%, goes to petrochemicals, which are then used in the chemical industries or are used in the polymer and plastic industries or other niche applications. So talking about the oil and gas industry overall, we're talking about an industry which is very mature, very chaotic. You never know about the trends of world economics, so it can either go up or it can go down or stay the same. So regarding job security, I will say that maybe you are always hanging on this thread, maybe not always. You can ensure that you're going to be working in a production site. Talking about the refinery, I will say that you have a job which may be more secure compared to the upstream section. Either way, let's focus into the downstream section, which I think is more relevant for chemical engineers. The very first part will be refinery, and remember that refinery is essentially the separation of these valuable materials, which are then separated in several stages depending on market demands and requirements. So the very first ones will be LPG, which is liquid petroleum gases. Those go mostly for fuels. Then we have the naphtha section. One of them will be for gasolines, but one small section will go for petrochemicals, which we're going to be talking about later on. But for now, let's focus to the fuels: gasolines, jet fuels, diesels, gas oils, and lastly, asphalts or bunker oils, which are mostly not so liquid. They're very dense, very viscous, and not so friendly for the environment. Talking about the petrochemicals, guys, this is the section I will say is the dream for a chemical engineer, because you have a lot of ways in which you will be converting these materials, these naphtha materials, into very valuable materials such as ethylene, propylene, which then can be converted to plastics, or maybe we're talking about methanol, which is created industrially. Maybe we are talking about the PTX, benzene, toluene, xylene, or other type of materials which most likely are going to end up as polymers or plastic. By the way, guys, if you want to learn more about the oil and gas industry, I prepare some courses out there which explains very deeply the refinery processes, all the products, all the specifications that you will typically see, how the processes are performed, under which type of conditions, temperatures, pressures, catalyst, equipment, and so on. And if we're talking about the petrochemical industry, which is also very important, you can see what are the typical feedstocks, typical processes, conditions, and final products. By the way, guys, I also prepare a webinar for energy review, which is based on PP's review of energy, essentially how's the market and production of energy going, which is of course based mostly into fossil fuels, namely oil, gas, and coal. But you can see other type of energy such as nuclear, wind energy, even electrical batteries, how are they going, lithium, so on. So definitely check it out. The next industry is based mostly on petrochemical industry. So once that you have all these petrochemicals that we don't produce just for the sake of production, but because they have applications. And we're going to be talking about plastics, polymers, and resins. As you can imagine, guys, since the 50s, 60s, plastics have been growing tremendously. Actually, I would say in the last 30 years, the use of plastic has been exploding. You can find them almost everywhere. Automobiles, you can find them in equipment, for instance, this camera, you can find it in computers, you can find it at home, you can find it in plastic bags, you can find them in straws, you can find them also in pipelines used in the industry and in residential areas as well. So plastics are everywhere, and working in the plastic and polymer industry should be great. Actually, whenever I meet someone that works in plastic and polymer industry, I don't know why there's like this great sensation of they actually loving their work or their jobs, because they really enjoy the chemistry that goes behind polymerization and all the processes, because typically you will have reaction for sure, you will have pumping, you will have compression, you will have a lot of heating, cooling, and the art of also extrusion is great. Nonetheless, we need to say that this industry is not so green, in the sense that the materials that we are producing are staying longer than expected, and there's a problem with the production and consumer, in the sense that no one wants to really care about the garbage. So that's regarding the plastic industry. It's a monster of an industry, and actually work there, I really love it. But to be honest, we need to consider the environmental impact this industry is making in our world. This industry is mostly not related to chemical engineering, but you need them. And I'm talking about the building and construction industry. And I know that maybe you're thinking immediately about civil engineers or mechanical engineers, maybe even electrical engineers, but you don't figure out how a chemical engineer goes into this industry. And first things first, remember that construction requires materials. These materials are typically produced by a chemical engineer. If we're talking about concrete, maybe we're talking about bricks, glassware that may go in your windows. Maybe we're talking about the aluminum frames that go in your window or doors. All that is eventually produced by a chemical engineer. So that's why I didn't want to miss this industry, because I know there's a lot of chemical engineers working in this type of industries. Now, this industry is for sure the one that you want to bet, and it's the wastewater treatment industry. And what I mean with wastewater, I mean both residential wastewater, industrial wastewater. First things first, we need it for drinking, so potable water, water that you can drink. Number two, we use water to clean stuff at home. So maybe you want to wash yourself, go and take a bath or a shower. Maybe you want to clean your hands. Maybe you want to clean your dishes. Maybe you want to clean your clothing. That's water that we need to clean and that we need to eventually treat as well. Another aspect that you may want to consider is also watering your garden, your grass, whatever. That also requires clean water. And lastly, but not least, we require water to flush down the toilet. Let's talk about the industrial use of water. Number one, we require water as a solvent. Actually, water is the most important industrial solvent. It is extensively used in any kind of industry. So actually, it's very hard to imagine an industry that does not require water for industrial use. Number two, maybe we require water for heating and cooling purposes, in the sense that we use it as a refrigerant. And number three, we may use water as a raw material that will either react or be formed and end up in our final product. If we're talking about soda, we will require water as our main component, hence a raw material. So talking about the name that should not be named, the famous COVID-19, probably wondering about pharma industry. And yes, pharma industry is skyrocketing. It was growing already at a constant pace, but now we have seen unprecedented growth on the pharmaceutical industry. And a lot of chemical engineers can squeeze their way in. And why? Because there are a lot of reactors and bioreactors. We are talking about synthetic chemicals, and we're talking about biomaterials or biochemicals. So the typical fit for a chemical engineer was before synthetic drugs. So one great example will be aspirin. which is a chemical, actually a acid, acetyl salicylic acid. As you can imagine, you require a chemical engineer working in chemical reactors in order to improve the performance of the reactor. And not only that, once you have your final product, how to separate it, how to convert it, and how to market it to your final customer. In the other hand, we have bioreactors, which technically speaking should be operated by biotechnologists or biotech engineers. But to be honest guys, a chemical engineer can be taught about biotech and operate such reactors. So if you're into pharma, definitely go out and check out this industry. I can maybe think about 2, 3, 4 degrees that have it easier than a chemical engineer to end up working there. Number 1 will be a pharmaceutical, someone that studies that directly. Number 2 will be a chemist, someone that actually works at the lab and knows about chemistry. Maybe a biotechnologist, because they already know the chemical part and the biotech. And of course, the chemical engineer. This industry is very large, and actually I don't want to treat it as the unique chemical industry. To be honest, there's a lot of engineers overlapping in this industry. And I'm talking about the food and beverage industry. When I mean the food and industry beverage, I really mean most of it. Since the materials, since the feedstock, since the raw materials, refrigeration, heating, cooling, evaporation, freezing, all these processes may sound familiar, and they are, because these are very common to do in the kitchen, but also for us chemical engineers, imagine working with huge amounts of meat or huge amounts of vegetables, huge amounts of fruit that you may, I don't know, maybe end up working with juices. Maybe you want to make some soda, maybe you want to end up with a sausage, maybe you want to end up with a chicken which is frozen. There's a lot of applications on that case by itself, but also we are talking about the food additives. There's a lot of materials that are added as chemicals for those foods. We're talking about food preservatives, colorants, edulcorants, and other additives. Not only that, we can talk about beer itself, which will be a unique industry by itself, or we can talk about wine making, which can be also a huge industry to talk about. So that's why food and beverage industry is huge for chemical engineers, because you can work in mostly any part. Actually, I have some friends that work in cookie making. I have some other friends that work in ham making, on sausage making, and they are working in very chemical engineering processes. For instance, in mixing, in cooking, in heating, in evaporating, and so on. Pulp and paper industry. And I really don't like to cite this example because automatically everyone thinks about paper itself and they think that paper is dead because everything has gone online or digital. And that's not the case. Actually, we use pulp a lot. Just try to picture all the packaging that's occurring. You typically have both plastic and cardbox. Pulp and paper is also used in a lot of things such as building materials, or more importantly, hygienic material. So before I told you guys that food and beverage is an industry that's going to be out forever, well, I'm pretty sure that this is also going to be out forever. So we need to be honest with this industry. It might not be the most exciting industry. The technologies may not be the best or the most innovative ones, but for sure this industry is going to be here for the following years to come. So far we have been talking about only materials, so chemical substances, products, physical things. But let's go to the other side of the equation. What's up with the energy? Are chemical engineers there? Can we work in the energy production sector? The answer is yes. And I really love this because chemical engineers can do a lot in the energy sector. And what I'm going to be doing is splitting this into 2 parts. Part number 1 will be the traditional way of making energy, which is using fossil fuels such as oil, gas, and coal. And part number 2 will be using renewable fuels. So let's go into the very first part. Traditional ways of making energy. And the most common way to do energy, or at least electric energy, will be burning fuels. And yes, as you can imagine, oil and gas, energy, electricity, all bind together right now. So you burn fuels such as natural gas or maybe gas oils or so, and you are going to evaporate water into steam, and steam is going to be moving this turbine mechanically, and this turbine is going to be working with the generator and form electricity. Now let's go to the non so traditional way of producing energy, and I think this is going to be a great hit for chemical engineers if it's not already a hit. So we're talking about solar energy, typically with solar panels. We're talking about wind energy with windmills, and so we're talking about electrical batteries, improving their capacities, their relationship between energy and volume, and of course nuclear energy. So these are the trends that are coming up next for chemical engineers that want to focus in the energy sector, and for sure this is a very promising industry. And the last industry I want to share with you guys will be the fine chemicals or specialty chemical industry. I will be just mentioning some examples because I am actually preparing a future video on this specific industry, which I really love because it's all about chemical engineering. A chemical engineer is someone that converts raw material into very valuable chemicals that are used in society, and what you want to do as a chemical engineer is always look for chemicals that convert into very high price materials. An example of fine chemical could be a catalyst that, if you compare the price per mass versus, I don't know, maybe sulfuric acid or other bulk chemical, will be tremendously high. Other examples are very specific polymers that work only, for instance, in certain processes or certain industries. Another example will be nanoparticles, nanomaterials that may be used in research or at labs, that you know that you are not producing huge amounts, but definitely you are selling them very expensive. We're talking maybe about special pigments for certain applications. We're talking about some type of pharmaceuticals or medicines that sell for very high amounts per unit mass. But anyways guys, the fine chemical and specialty chemical industry are for sure great and actually are growing, and they are very innovative. So if you're into that, if you love chemistry, that may be a good fit for you. Nonetheless, if you want to check out my future video for fine chemicals and specialty chemical industry, ensure to subscribe and click on the notification bell. So that's it guys, the most relevant industries in which chemical engineers can work. I know that maybe the list can be very traditional, but those are the industries that most of the chemical engineers are selecting. And of course, when I say chemical engineers, I refer to those chemical engineers going to actual chemical engineering, because there are a lot of chemical engineers selecting not to go to these typical traditional paths, and I will be making a video on that as well. A lot of chemical engineers going into finance, maybe into banking, insurance, e-commerce, making their own business, going to venture capitalist companies, and maybe into startups. There's a lot of things that chemical engineers can do, so that's great. But anyways guys, that was the list I wanted to share you. Let me know if you have any doubt or comment on the industries, and especially if you think I missed a important or very relevant industry for a chemical engineer. I'm looking forward towards knowing what is the typical industries or what are chemical engineers in your area selecting or going for. Maybe it's not oil and gas, maybe other type of industries. So it will be great to share that as well. And that's everything on my behalf. I'll see you in the next video. Acetyl salicylic acid.